Hey guys, this is Coach Hardy here. I just wanted to send this video out to you guys because this provides you with a visual that can help you solve these equations that you guys are currently doing. And I really think that this will help many of you. So check this out. So this is a scale, like a balance. Okay, you might have seen this in science or something like that. Basically, the way this works is this side has to be equal to this side in order for the scale to balance. Okay. If, say, the left side is heavier than the right side, obviously you would see it look more like a seesaw or something like that. Okay. So when we're solving equations, we want both sides of our equation to be balanced. So I'm going to go through a couple of problems that you've seen so far in the video that Coach Lee's put together. The first one was x plus 3 equals 8. Now we want to view this scale, okay, as an equation. This is our visual. So we want both sides to be equal. Now the whole point of an equation is to find out what x is. So this x right here, we want to find out what it is. So in order to find out what x is, we've got to get this variable by itself or isolated. Okay, so we've got to ask ourselves first with this equation, we need to ask what is currently being done to this x. So in this case, 3 is being added to x. So we have to undo that to solve for x, or we have to do the inverse operation. So in this case, because 3 is being added to x, we've got to subtract 3. Now, like I said, for the equation to be balanced, we have to do it to both sides. So if I subtract 3 from this side, I also need to subtract 3 from this side. So let's solve. 3 minus 3, well, that's 0. Okay, so that's gone. And then we are left with just x on this side. Okay, I'm going to put my equal sign there. And then 8 minus 3, that gives me 5. So that simply tells us that x equals 5. Okay, so you just solve that equation. Now, in order to check to see if we solve that equation correctly, let's take 5 and let's go put it back in place of x here. So we would have 5 plus 3 equals 8. Now, 5 plus 3 is 8, and 8 equals 8. So we know we just answered that problem correctly. Okay, so that is an addition problem. So now, one thing that I want to show you guys is if I did not do the same thing to both sides, what would happen? So I'm going to rewrite this problem down here. X plus 3 equals 8. So we said we had to subtract 3 from both sides. So I'm going to subtract 3 from only one side. Okay, so that would be 3 minus 3, which is 0. So I'm just left with x. And I'm just going to do it to that side. So I would be left with x equals 8. Well, x equals 8 is not the same answer that we got with x equals 5. And if I were to go back up here and plug in 8 for x, 8 plus 3 is 11. And 11 does not equal 8. So that's why it's important that we do it to both sides. Okay, I'm going to erase that, and I want to do it for a multiplication problem for you guys. One second. Stuff's kind of hard to erase. Okay, let's look at a multiplication problem. You've seen this one already in your pages in your math binder. So we've got 7x equals 42. Okay, so we've got to ask ourselves, what is being done to the x here? Well, the x is being multiplied by 7. So we've got to do the opposite or the inverse. So the opposite or inverse operation of multiplication would be division. So we have to divide by 7 on both sides. Remember, you have this balance here. Whatever I do to one side, I have to do the other to keep my equation balanced. 7 divided by 7 is just 1. So we're left with x equals, and then 42 divided by 7 is 6. And then I just can go back and plug in 6 for my x here. And I know that I get 7 times 6 equals 42. 7 times 6 is 42, so we know that to be true. Okay, one more that we're going to do. I want to show you guys a division problem, and that will be it. Okay, it's also another problem that you've already been doing. So x, well, 1 second, guys. X divided by 4. Hang on. Should be good now. X divided by 4 equals 3. So what is being done to the x? Okay, the x is being divided by 4. So we have to do the inverse operation of that in order to isolate the variable. So the inverse of division would be multiplication. So I'm going to multiply by 4 on both sides. Okay? So on this side, okay, I'm left with nothing but x. And 3 times 4 is 12. So x equals 12. If we go back to our original problem and we plug in 12 for x, I would have 12 divided by 4 equals 3. And we know because 12 divided by 4 is 3, 3 equals 3. So I know I got it correct. All right, guys, I hope this helps. This visual right here, it should be something that you can keep in your mind when you're doing these problems. Good luck.